File handling in Golang is pretty easy, but it can come with a lot of challenges if not handled properly. Quick reminder here, this video is mainly for beginners because it will give you a short introduction to all the essential file operations you will need in Golang. But still, you might learn a thing or two if you are more advanced. Alright, there's a lot to know and try out regarding file operations in Golang, like file seeking, concurrent access of specific files, or for instance temporary files. However, this video solely focuses on the most basic file operations that you can use to really get you started with files in Golang. Also regarding file operations, there's a lot of potential improvements that you can make to, for instance, basically handle larger files more efficiently. But I will probably make a separate video just about that because it is such an important topic. Now also it is important to note that this video is not going to highlight any real-world use case, because really these file operations are more like something like a Lego block, for instance, than anything really special. Alright, let's just start with the most fundamental operation to really prevent any errors if a file does not exist. And this is actually checking if a file exists. Now I've created a simple example.txt file in the project here with just the contents of okay, that's pretty cool. And we want to check if this file exists in our project or not. So for each separate functionality I'm going to demonstrate in this video, I'm going to create a separate function. So let's just create a function here called fileExists. And this fileExists function takes in a path, which is a string in the end, and it can return a boolean and a potential error. And generally, it's good to know that there are a lot of ways to basically handle files in Golang, but I'm going to pretty much demonstrate here the lstat functionality. Okay, so let's get started with basically ignoring the file information we are going to retrieve from the lstat function. And this lstat function lives in the OS package. And in here, we are going to specify the path. Now basically this lstat functionality just retrieves file information really without following any symlinks. And a symbolic link is pretty much like a shortcut to another file. We can actually leverage this error to pretty much just check if the file exists or not. So if it does not exist, then the error is basically not empty. Now also it's good to know that obviously this error can return other errors as well. So for instance, a common issue would be like a permission denied error, and we are going to check this here in a minute. And with that we can actually leverage the errors.is functionality. And what we're going to check here is the error basically, and then the target. And the target is going to be error not exist, coming from the OS package. So if this basically exists, then we say return false and then nil, right? Because obviously the file does not exist and we do not want to return the error. Now generally with that you can obviously return the error here directly as well, but I'm going to just use nil because we only want to check if the file exists, right? I want to ignore this error if it really was an error. Now what you could also leverage here is pretty much the os.isNotExist functionality, right? And this pretty much more or less does the same thing. And this errors.is functionality really checks the exact error, right? And if the error basically wraps another error, then this errors.is functionality just checks basically if there is any match with the target here, and if the error in the error wrapper basically is related to this file not existing error. Now hopefully this was kind of clear. I've actually made a video about the errors.is functionality, so feel free to check out this video as well. Anyway, in the end we can obviously say return true and then nil as well, because we don't get like any error and retrieve the file information successfully from the lstat function, right? So we can say that the file basically exists, and if still there is an error, I think can say return true, but we can also say return false and return the error itself. So in the end, it really depends on the functionality you want to handle, but for demonstration purposes, I'm going to just say false here and return the error, because basically I do not want to check the error in the main function. Obviously you can improve this functionality to handle the errors much better than I do basically, but I'm going to just say false and error here, and then in the end we can leverage this function in the main function here. So what we can say is basically define a simple path called example.txt. Now at this stage we are not going to cover basically relative and absolute file path, or for instance cross-platform path considerations. This is here just for beginners. And like I said before, I'm going to ignore the errors, so please do not do this at all, right? You should always handle the errors gracefully here. And then we call the fileExists function, and then we say path. And then we can say fmt.println fileExists, and then we say fileExists. Now, if we run this code now, we will actually see that the file exists, obviously. And if we are going to delete this file and then run the program again, we will actually see that the file does not exist, which is the correct behavior. Alright, let's jump to the next basic operation, and it's going to be the createFile operation. So I'm going to basically kind of create two functions here. So I'm going to cover two versions of basically creating a file. The first version that I'm going to demonstrate right now basically creates a new file or truncates an already existing one to 0 length. You might wonder, what does that actually mean? I'm going to demonstrate that in a minute here. Now, the second version basically creates the file only if it does not exist already. Now, you could leverage the fileExists functionality we had before, right? But I'm going to show you basically how you can do that while trying to create the file directly. So let's just cover the first version first. I'm going to create the createFile function here with this path string, obviously, and then it returns an error in the end. And then we're going to return nil here directly, because in the end, if all the functionalities succeed in this function, then basically we do not have any error at all. Now, what you could also do is return the file here directly, but then you obviously need to close the file to clean up memory resources. So to really simplify things, I'm just going to return the error here, right? And then we are going to leverage the os.create functionality, and in here we're going to specify the path. Now, this create function basically returns the to be created file and a potential error, right? And this is now the functionality of creating a new file, or if the file already exists, it truncates the already existing file to 0 length. Now, truncating basically means that it removes all the contents of the file itself, but it keeps the file. So in the end, we are kind of overriding the contents instead. Right, so let's check the error here. So if error is not equal to nil, we are just going to return the error, right? And then we are going to say defer file.close. I've also made a video specifically about the defer keyword here, so feel free to check out this video as well. But generally, it is always important to kind of close the file to clean up resources, as I said before. And why does this close function actually exist? Basically, whenever you open a file in Golang, it consumes system resources like memory and obviously a file descriptor. Now, if you don't close this file after all, you might run out of resources or lock files unintentionally. And we want to avoid these kind of memory leaks at all costs. So here we are really closing the file to clean up these resources, and we use defer to really ensure that the file is always closed when the function exits. Right, so let's quickly leverage this function here in the main function. And what we're going to say here is basically directly in fmt.println. Obviously, you can optimize this, but we're going to say file created, and then we call the createFile function at the path. And then I'm going to quickly create another fmt.println. Now we're going to say file created if not exist. Here we say createFile if not exist. And I'm going to create this function quickly here, so createFile if not exist. This is actually the second version of the creating a file functionality. And this, like the other function as well, just basically takes in a string and returns a potential error. I'm going to return nil here. Then I'm going to move this function to the end. There we go. And now let's just quickly demonstrate this behavior here. So let's just run go run main.go. And what we'll see is actually file created nil, right? So the error is nil, which is as expected, because we are going to create the example.txt file. Now what you will see here, because it truncates the content, we do not have any contents in the file at all. So let me quickly delete this example.txt file here. And then let's just run go run main.go again. And as you can see, we do have the example.txt file again, right? So the creation of the file now works. Now let's quickly create the other functionality of creating a file here. So what we're going to do is we basically leverage the os.open file function. And this is going to be interesting because now we have flags that we can define and we have a permission. What does that actually mean? So first, this open file function basically opens a file with predefined flags that we can define. Now these flags generally define how you want to interact with this specific file. And we are going to create 3 flags here. So the first one is ORD WR, which basically stands for open for reading and writing. And we are going to combine the flags with this bitwise operator, which basically stands for a bitwise OR. Now I'm going to probably make a separate video just about all these bitwise operators, but in the end you can think of this kind of OR as a combination, so it combines specific integers in the end. This is a really vague explanation, but hopefully you get the point here. So we are trying to combine multiple flags together so that the openFile functionality basically uses all of these flags. So then the next flag is going to be O and then EXCL, which basically stands for kind of, it returns an error if the file already exists. This is all it means. And then we're also going to leverage OCreate. And this just creates the file if it does not exist. So with this flag here, it is basically going to create the file. And then we are also going to define the permission here. So we are going to say O666. In the end, this O666 is an octal number that basically defines the default permissions for the created file. So in the end, we are going to take care of these 3 sixes here. So the first 6 basically means that we have the read and write permission for the owner. The second 6 basically means that we have to read and write permission for the group. And the third one basically means that we have to read and write permission for others as well. Now, if you want more information about these flags and this octal number, just Google it. It is really easy to understand. And obviously this openFile functionality returns the file itself and a potential error. So I'm going to quickly format this here so you can actually see things. And then obviously we're going to check for the error. We're going to return the error itself if there's basically an error. And obviously we need to close the file in the end. Now again, we could just return the file here directly and then close it in the main function, but I'm going to keep it really simple. So if we now run this code, we will actually see an error that the file example.txt already exists, right? So it tries to open the file with this os.ocreate flag, and therefore it tries to create this file. However, it already exists, and therefore it is going to return this error that this specific file already exists. All right, so with that in mind, we have now 2 functionalities for creating files. But what about writing to a file, right? Because obviously in the end we want to write things to a file or even read. But let's just first cover writing here. So we're going to create a new function called writeFile. And in here, we're obviously going to define the path and then the data, which is going to be a byte slice. And in the end, we can obviously get an error back. Now, funny enough, what you could also do directly in here in this createFile if not exists, we could also leverage directly the write string functionality or generally a write function. I'm not going to do that, obviously, because this function is just for creating the file if it does not exist already. We're coming back to the writeFile function here. In the end, this will just write directly to the file. So we're going to say os.writeFile. Then we're going to say the path. We are going to use this specific data. And then we are going to define the octal number or the file permissions again, which is 0644. Now again, this 6 basically just means that we have reading and writing permissions for the owner. And then we have these 2 4s, which basically only display the reading permission instead of the writing permission. Then in the end, we are going to return this. So as you can see, this writing to a file is pretty straightforward. Now, obviously, there are multiple ways to writing specific data to a file. And also what is important to know, because I'm going to demonstrate this in a minute here, that writing is not equal to appending. Obviously, writing just overwrites the content of a file and appending just appends something to a file. So what we're going to do with this os.writeFile functionality is that we are going to overwrite the contents of the file here. So let's demonstrate this in the main function again. What we're going to say is fmt.println writeFile. And then we're going to say writeFile. We're going to define the path here, and then we say basically a byte slice, which in the end is a string. So what we have here in really easy terms, this is again a vague explanation, but it is a magical way of converting a string to a byte slice. And we are going to say hello world. And what we will actually see if we run this code here is that we actually have no error, which is good. And if we open the example.txt file, we do have hello world. Now, what if we run this again, right? Let's just say go run may not go. Obviously, we do not get 2 hello worlds, and that's the actual purpose of writing to a file. So let's just create the file functionality of appending something to a function. So what we're going to say is basically appendFile, and then we're going to leverage the appendFile function that we are going to create in a minute. And then we are going to say, okay, that's pretty cool, right? With a space in between. I'm going to format this here quickly. And then let's just create this append function down here. So appendFile, we obviously do take the path in, right? And then obviously some data byte slice. And in the end, it returns an error. Now right here, we are going to open the file again. So we're going to leverage the openFile functionality again. Now what does actually these 2 flags mean? So only basically means that we only want to open the file in a write-only mode. Right? So we only want to write things to a file, we do not really want to read anything. And the next thing is append, which is another flag that lets us basically append things. So that's pretty cool. And in the end, obviously openFile returns a file and an error. And if there is any error, we are going to obviously return the error directly. And if not, we are going to say file.close. Always clean up your resources when handling with files. And then in the end, we are going to leverage the file.write function, because obviously we didn't write anything yet to this file or append something to the file. And what we're going to say is data. Right? And then we say error, because obviously this can return an error. And this write function just in the end writes all the data to the file. And obviously we can enhance this error checking as well for this appendFile functionality, because obviously other things could go wrong as well. But I'm going to just return the error here directly. Okay, let's just run this function. So go run may not go. And we do not get any error back. And if we open the example.txt file, we now have the appended data, which is pretty cool. Okay, basically we appended things to a file, we wrote things to a file, we created the file itself. How about reading the file? And there are a few ways to actually read the contents of a specific file. I'm only going to basically use os.readFile, but you can also, for instance, leverage io.readAll. Now this example here only demonstrates really reading the contents of a file for smaller files. You can also leverage, for instance, buffered reading to read larger files with, for example, the buff.io reader. But I'm going to make things here really easy. I'm going to also make a separate video just for this buffered reading as well. But generally, I always recommend using this buffered IO whenever possible, because in the end, it is much more efficient than this version here. Okay, so let's create this file, readFile. In the end, we are going to take in the path again. And then this returns a byte slice and a potential error, right? This byte slice basically just represents the data in the file or the contents of the file. And then we're going to say readFile, and in here we use the path itself. Now what's important to know is that we are reading the entire content of a file into the memory at once, and that's why it's so inefficient, because obviously these files can be gigantic. Again, this readFile returns the data and then a potential error. Now if there is any error, we are just going to return nil and error, and then in the end we can return data and nil. Now we can also enhance this function by just removing this and obviously directly return the result and a potential error here. So let's demonstrate this readFile functionality. So going back to our main function, we're going to say basically data and then a potential error, readFile and path. Now again, I'm going to ignore the errors here, and then we are going to print the file content basically, which is just a stringified version of the byte slice, which just returns the byte slice into a simple string. Right now, if we run this code again, what we'll actually see is the contents of the file, which is the correct content. Okay, that's pretty cool. How about deleting a file? Because obviously we now read the file and now we want to delete the file for whatever reason. So we are going to create another function, deleteFile. In the end, it also expects a path again, and then it can return a potential error. And in here, we are going to leverage os.remove and then path. Now, obviously, removing a file could potentially fail in some use cases. And that's why this os.remove actually returns a potential error, right? So this os.remove just deletes the file at the specific location, which we've specified here with the path parameter. And obviously, we can improve this functionality by checking if the file basically does not even exist, right? Because obviously, if it does not exist, we do not want to delete the file. And instead, maybe we want to not return an error and maybe just a simple log, for instance, right? But this is really up to you. This delete function just covers the most fundamental deleting of a file functionality. Okay, so let's leverage this function here again. And what we're going to do in the main function is we are going to basically say fmt.println, and then we say deleteFile, and then we say deleteFile path. This is some kind of cleanup just for our main function. And now if we run go run main.go, what we'll see in our file explorer is no example.txt file. And therefore this file is actually deleted. So that is pretty cool. We now have a really simplified process of creating a file, writing, appending, and reading and also deleting the file. And now maybe you are curious, okay, what about retrieving the file size, for instance, or other metadata information like the last modified time? And with that, we can actually leverage the lstat functionality again. So we've already seen this functionality, but we can leverage this again to kind of get the file stats here. Now, in the end, we're going to return a int64, a time, and then also a potential error. So int64 is basically the size, which is the file size in the end in bytes, right? The modification time, which is the mod time, which is time.time, and then a potential error. So again, we are going to leverage here the os.lstat function without caring or without following the symlinks. And then we're going to define the path here. Now, if the error is not equal to nil, obviously we want to return -1 because there is no file size. Then maybe an empty time struct here, and then the potential error. Now, if this succeeds, right, if we can get the information from the file, then we can basically get the size by leveraging info.size. And this again returns the size of the file in bytes. Now then we can get the mod time, right, by just saying info.modTime, and you can get a lot of other metadata information as well from this lstat functionality here. And then in the end, we are going to return the size, the mod time, and nil. Now let's go to the main function and demonstrate this behavior here. So before actually deleting the file, let's just say size, mod time, and we are going to ignore the error again. And then we're going to say fileStats path, and then we are printing these two information here. So file size, which is the size, and the mod time, which is the file last modified time. Now, if we run this main function again, what we will actually see is the last modified time here, which is the correct date, and then the file size in bytes. Okay, that's cool. How about copying a file? So let's just demonstrate this functionality as well. Now, in the end, this copying of a file functionality is a bit more complicated because in the end, we are going to read from a source file and write something to a destination file. And we are going to leverage io.copy just for efficiency's sake. Now, this functionality just handles the buffering internally, so it is already quite efficient, and therefore it makes it even suitable for larger files as well. So let's just create this file called copyFile, and in the end it takes in a source path and a destination path, which are both of type string. In the end, we are going to maybe potentially return an error here again. So let's just demonstrate the io.copy function here. And what we have is a destination, which is of type writer, and a source, which is of type reader. So we cannot really easily define the paths here. And therefore, we are going to basically open the source path and potentially also create the destination path. Because in the end, we are going to copy the file. And therefore, the destination file does not hopefully exist already. So what we're going to say is source and then error. And then we say os.open source path. With that, we actually get the file descriptor of the source path. And in the end, this kind of copy function here has the reader interface, which is a really simplified reader interface here, which just has the read function, and the writer obviously has the write function. And because this return file descriptor os.file basically fulfills the reader interface already, we can leverage this source here in our io.copy functionality. And then in the end, we are going to basically say if error is not equal to nil. So if there is an error, we're obviously going to return the error. And then notably, we need to close the file descriptor here again to clean up resources. Now we're going to quickly create the destination file here with os.create. Obviously, we can leverage the other functionalities we've created before, but just to repeat and learn, right? I'm going to repeat myself here. So basically, if the error is not equal to nil here again, we are just going to return the error. And now because we've created the kind of destination file, right, and this returns this descriptor again, we can say dest.close again, right, in the end defer to clean up the resources. And then we can leverage the io.copy, which in the end takes in the destination and the source. Okay, and then we are going to basically get the error here again. And this copy function returns the number of bytes basically copied to the destination file and a potential error. So we are going to just say if error is not equal to nil, we're going to return the error, because now we are going to return des.sync. Now what does this actually mean here? Basically this function, so des.sync actually returns a potential error as well, but generally des.sync, so we are synchronizing the destination, basically ensures that the changes are written to a stable storage. Now obviously things can go wrong in the copying process, and I think this whole copying thing deserves its own video, because what is even a stable storage? But this is especially important for larger files here. So let's just go to the main function again, and let's just make use of this copyFile functionality. And basically what we are going to say is we are going to create a copied path, which we call copy.txt. And now we are copying the file, which is the example.txt file. And we are going to copy this example.txt file to the copied path itself. Now in the end, to clean up things, we are going to just delete the file, which is copy, right? And here we are going to pass in the copied file. But if we just comment this out and run the main.go file again, what we will actually see is a copy.txt file with all the content of the example.txt file. So let's just delete the copied file here as well. Now I think what is a really cool functionality as well is the listing all files functionality. And we are going to only focus on the most basic functionality of listing all the files at a specific path. Now you could also leverage, for instance, filePath.walk to like really recursively list all the files in folders, but we are going to make things really easy. So let's just create this function, listDirFiles. We are only going to list all the files, not the directories. And in the end, this returns a slice of fsDirEntry and then a potential error. Now this just basically returns a potential error, obviously, and then also a slice containing file entries, right? No directories. So let's just leverage os.readDir, and here we are obviously going to say dirpath. So let's just rename this to dirpath instead, because obviously we want to list all the files in a specific directory. And this just reads the contents of this specified directory here and basically returns entries and a potential error. Now if the error is not equal to nil, you know the drill, we just return basically nil here and the error itself. Okay, and because obviously this entries just returns the directories and files as well, we need to loop over it and basically only return the files. And how can we actually do that? By actually leveraging a new slice called listedFiles. And we are going to make use of make here, which creates an empty slice. So this make basically just initializes the slice with 0 elements, but with a capacity to grow really efficiently. And then we are going to loop over the entries here, and then we're going to check if the entry is not a directory. We are just going to say listedFiles and then append listedFiles and then entry. So basically with this functionality, we are just going to create a new slice called listedFiles. In the beginning, it is of size 0, and then we are going to append all the files in this directory to the listedFiles slice, so that in the end, the listedFiles slice contains all the files inside of a directory we've specified. And then we are going to return the listedFiles and obviously nil as an error because we do not get any error here. All right, and then in the end, in our main function, what we're going to do here is just basically print something. Then we basically retrieve all the files inside of our current directory here. and then we're going to print the listed files. Okay, so what we're going to do is go run main.go, and what we'll actually see is all the files here. So don't be really confused with this dash here in between. Basically, it's just a byproduct of how Go's format package really formats the slice when printing it, right? So what we can do instead, for just listing all the file names, we can just iterate over the listed files, so listed file range. Then we can just kind of print the listed file.name. So if we run this Go file again, we actually see the Go mod file, the Go sum file, and the main.go file. And then this slice here, because in the end, they are just not names itself. These are all FS_dir entries. And this in the end really depends on the formatting itself, how this listed file, how this specific slice of dir entries are basically formatted while printing it. Alright, and that's all you need to know about basic file handling in Golang. If you also want a quick crash course about the beautiful Golang concurrency features, then I highly recommend watching this video here. Anyway, I hope this was useful. Thank you so much for watching, have a lovely day, and bye bye.